Okay, so now we're going to look at two other techniques for estimating an integral or estimating an area under a curve. The first one is a midpoint Riemann sum. Riemann because it is still using rectangles. And you will see in a minute, midpoint is not a clever name. It is very descriptive of what we're going to do. So let's say we have gas data here. Gas is being pumped in a car, and at different time intervals, every 4 seconds, we've been able to assess the rate that the gallons of gas are coming into your car in gallons per second. And so we're going to use a midpoint Riemann, 3 equal intervals to calculate how much gas was going in the tank over the 24 seconds. So if my data goes from 0 to 24 and I want 3 equal intervals, okay, 0 to 24 divided over 3 intervals means 8-second intervals. So 0 to 8, 8 to 16, 16 to 24. Now, one mistake I see students make often when we're doing a midpoint Riemann is to do your first interval, for example, 0 to 8, and then your next interval you think starts at 12. We always start our next interval where our last interval left off. So 0 to 8 means 8 to 12, or excuse me, it means 8 to 16 if we're going to be consistent with, and then 16 through 24. All right, little graphy graph, 8, 12, 16, 20, 24. Let's do 2, 3, 4, 5. This is 0.6, and this is 0.1. So 0 is 0, and 4 is 0.3-ish. 8 is 0.4-ish, and 12 is 0.5-ish, and then 16 comes down again a little bit, and then 20 comes down again, and then 24 comes down. So we've got something that looks like that. Okay. When we're doing a midpoint Riemann, just like it sounds, we describe our Riemanns based on where we're going to get the height for each rectangle. In a midpoint Riemann, we're going to do the height at the middle of each x interval. And I will always make sure you have data set up so that when you create an interval, for example 0 to 8, that you are given the height in the middle. If you are guessing the heights on a midpoint Riemann, you're not doing it correctly. So I will always give you an expanded enough table so we can do a midpoint Riemann so that every interval will have a middle y value or function value to use as your height. So from 0 to 8, we're going to use the height of 0.34. Now, if you want to think about these as 2 separate rectangles, you can do that. Or one big rectangle, it doesn't really matter. It's either 2 rectangles that are each 4 by 0.34, or it's one big rectangle that's 8 by 3.4. Second rectangle starts goes 8 out to 16, and the height is at that 12 value. Now, midpoints can sometimes be awkward to draw in. I'm not super worried about necessarily how they look all the time, as long as we're using the correct calculations. You can see the midpoints kind of have a nice mixture of a little bit over, a little bit under, kind of sort of evens things out. And then my last one, my 16 to 24, the height at 20. So some students kind of think about it's like kind of doing sort of a right and a left Riemann, like a right, then a right, and then a left together. So I don't know. I tend to just kind of look at it more as the table and say, okay, here's the middle values. So my calculations are going to be, bring this down a little bit so I can see. My table is in the way. I need to shrink it down just a little bit. Okay. All right. So 8 times 0.34, 8 times 0.56, and then another 8 times 0.34, added together. I feel like I remember this being 9 point something. Did just do this problem a couple times. There we go, yeah. 9.92, and we should be paying attention. If we were taking 8 seconds times 0.34 gallons per second, the seconds divided out, and so all the values we got are gallons. We did 9.92 gallons. That's the total over the 24-second period. The total accumulation of gas across 24 seconds, given that at different points it was coming out or going into our tank at these various rates. Once again, data will be set up so that a midpoint will work, in that you will have a middle. If you don't see that, then you're doing something incorrect with how you're organizing your data. Most likely, the most common mistake I see is one interval and then starting the next interval at the next x. 0 to 8 means 8 to 16, and then 16 to 24. Nothing, no gaps, everything goes together. Trapezoid method. Trapezoid method is going to use one of the things I talked to you about with a trapezoid, and that's the fact that, we're going to do, actually let me fix this a bit. When we were looking at our trapezoids, when we were doing our areas, we talked about sometimes, and this is the sometimes I was looking for, our trapezoids might be kind of standing on their sides. When we do a trapezoid technique, which is not technically a Riemann technique, the trapezoid method sometimes is also referred to as Simpson's method. Simpson's method uses trapezoids to estimate, but we tend to group it under Riemann. It's just kind of all the different, some of the different techniques for estimating area under a curve. When we graph our data, so 1, 2, 3, 4, and then let's see, this goes, let's do 2, 4, 6, 8, 10, 12, 14, like that, okay. So 0 is up at 3, try to pick color, and 1 up at 5. So here's what I do with my trapezoids. The height part of the trapezoid is the interval along the x-axis. The y values for the function values, are the bases. So when I do my first trapezoid from 0 to 1, and we usually do as many trapezoids as the data on the table suggests. Okay, my first trapezoid from 0 to 1 is going to look something like that. And if I do my data, I do a couple more points here. Over at 3, it's 6. At 4, it's 8. At 6, it's up to 14. So let's say it's something like that. You can see right away how a trapezoid just is nice. It fits so much more nicely sort of under something that's curvy than a rectangle does. And so my very first trapezoid, trapezoid 1, area of a trapezoid is 1/2 times the height, which is along the x-axis, that's 1 unit, times the sum of the two bases, and in this case the bases are 3 and 5. So base for 1 and base 2 for my first trapezoid. The next trapezoid I do is going to repeat the 5. We're going to use the 5 and the 6 so this is trapezoid number 2. 1/2 times 2 this time times 5 plus 6. Trapezoid number 3, right here, is going to be 1/2, 1, 6 plus 8. And then trapezoid number 4, here at the end, 1/2, 2, 8 plus 14. Now I'm going to pull another screen up here and do a double screen so I can organize my work a little bit more. I can't really see what's going on. All right, so what did I do? My first trapezoid was 1/2, 1, 3 plus 5. Trapezoid 2, 1/2, 2, 5 plus 6. And then 1/2, 1, 6 plus 8. 1/2, 2, 8 plus 14. It's 4 trapezoids because I basically had 4 intervals. 4 from 0 to 1, 1 to 3, 3 to 4, 4 to 6. In this case, the intervals happen to change lengths. Notice that the base that ended one trapezoid starts the next one. So we go 3 to 5, 5 to 6, 6 to 8, 8 to 3 to 5, 5 to 6, 6 to 8, and then 8 to 14. So you can see the overlap. It's nice to kind of like line them up like this, and then you can kind of see that. That way you make sure you're doing all the calculations you need to do. Trapezoid method is a little fidgy because it's a lot of calculations, but I think it's a little easier because you don't have to think so much about, well, which heights am I using or not using, and numbers. You use every number. It's just a matter of when you use it. Use all the y values and all the intervals between the x's. That would be 4. This one would be 11. This one would be 7. And this one would be 22. And so this one adds up to be 44 something, 44 tons. This was a problem about pollution being released out of a gas works with the coal gas coming out. How much gas is coming out, the rate that it's coming out in tons per month. So based on these different rates, we're looking at a total of 44 tons over the 6-month period. At this point, what you should do is go to the practice part in the packet, the last page, and try those problems. And then you can look up on the key to see if you've done them correctly. And also, like I said, you should go back into the right and left Riemann problems and make sure you're comfortable doing those as well. We'll review all 4 types of problems and the work from the first set of notes for the unit, which we're back on whatever that March day was, that Thursday, last Thursday. So last Thursday, and then the notes from Tuesday, Thursday this week. We'll review all of that on Monday, getting ready for a quiz on Wednesday.